Okay, so we should have a pretty easy rest of the class period. I just want to go ahead and talk to you today about long division. Just a couple of reminders. Remember on Monday, that's when we're going to talk about the 1.9 and 110 homework. We'll have our quiz over that material next week, so be looking to the website for that, and I'll be mentioning it again. But tomorrow when I come in, I imagine we'll go ahead, pass back the quizzes, we'll talk about them, and then finish up with our SEL. Okay. I have it Tuesday, but I'm actually thinking about moving it to Wednesday so that I can guarantee we finish this lesson by Tuesday and not have to break it up again. But I'll make that decision tomorrow morning. Okay, so we started talking yesterday. This lesson is going to pull all of the previous lessons together, everything we've been talking about when it comes to the characteristics and features of a rational expression. And we started to graph our first one yesterday. So we started talking about slant asymptotes, or and you may refer to them as oblique. Okay, so I don't believe we did this together, so let me erase this, and we'll just go ahead and start over very quickly. So we want to go ahead and take our denominators, that's our divisor, we're going to divide it into the numerator, the dividend, and we're going to get our answer, the quotient, which is going to be our asymptote, in this case a slant asymptote. So everything you would do with these polynomials here is exactly what you did in elementary school with numerical values. In fact, let's go ahead and run through one of these real fast. Let's say I want to take 21 and I'm going to divide it into 676. Okay, so this is definitely going to be a trip down memory lane. So you go by digit, 21 won't divide into 6, but it will divide into 67. How many times? 3. So I'm going to go ahead and put a 3 up top. That's the beginning of my quotient. But now what do I do with that 3? We multiply by the divisor. 3 times 21 is going to be a 63. After you multiply, you subtract. Okay, so 67 minus 63, that's going to give me 4. And how would I continue? There you go. We're going to take the next digit, we're going to pull it down, and then we start the process all over again. So how many times will 21 go into 46? Only twice. So I'm going to put a 2 up here. Now, just like the 3 before it, 2 times 21, I'm going to multiply. I'm going to subtract one more time. Now, if you wanted to go ahead and get a decimal, we could put 0.0 and continue. But for our purpose, 4 is what? That's our remainder. Okay, so I know my quotient is going to be 32. We got a remainder of 4, and you were taught to go ahead and take the remainder and put it over something. What am I referring to? Starts with a D. Now the dividend, we take the remainder and we put it over the divisor. So this would be 32 plus the remainder over, in this case, 21. But that's just going to combine to give me a mixed number. Now, everything we did there is exactly what we're about to do with the polynomials. Now, very briefly, I'll go ahead and mention it. I've decided that I'm going to go ahead and just focus on long division. I'm going to try to find something if anybody's interested in synthetic division, but there are a couple of changes that might need to be made for a lot of this division. So if you're interested in that, I'll see if I can post it to the website, but we're just going to go ahead and do this. So my divisor, let's say I want to take 2x plus 1, and I'm going to divide it into 6x squared plus 7x plus 6. Okay, so hopefully this is also going to be familiar from algebra. I guess it depends on how far your algebra teacher was able to go. Now, both your divisor and your dividend, you want them in descending order of your powers. You see, for example, it has x squared, x to the first, and then your constant. Okay, so the way to do this is to always lead with the term that provides you your degree. So in the divisor, I want to focus on 2x, and right now in my dividend, I want to focus on 6x squared. So we don't need to worry about any of the other terms, just start with them. So let's say 2x times what is a 6x squared? 3x. So that's the first term in my dividend. So I'm going to put 3x up top. Now, just like we did before, once I determine my first term, I'm going to multiply it by the divisor. So I'm going to distribute 3x times 2x. There's your 6x squared. 3x times 1, there's 3x. And what's super important, you should be lining up your like terms every time. Now, if you're missing a term, for example, if it just goes from, say, an x squared to a constant, if you're missing the x to the first, you have to put a 0 in there, which is basically a placeholder. Okay? So when I multiplied 3 times 21, we got 63. What was next? Then we subtracted. So I'm going to go ahead and subtract this binomial. But when I subtract them, that changes their signs. So notice 6x squared minus 6x squared, they're going to cancel. This is actually 7x minus 3x. And that's going to end up giving me 4x. Okay. Well, what do you think I do now? There you go. The very next term, you go ahead and pull that down, and you start the whole process over again. I'm still going to stick with 2x, but now I want to match up that 4x. Okay, so 2x times what would give me that 4x? 2. So because it's a positive 2, I'm just going to put plus 2. And now I want to distribute this 2 across the divisor. So 2 times 2x, and then 2 times 1. Once you multiply, then you go ahead and subtract. Okay, so 4x minus 4x, once again, they are gone. And then it looks like my remainder is going to be what? 4. Now, this is what we're going to be interested in. This is what's going to be happening the majority of the time. Because my power in the dividend was a 2, it is 1 more than the degree of the divisor. This mx plus b slope-intercept version, this is what we're looking for. This is going to be my slant asymptote. Okay. Now, there are people who's probably going to wonder, what do we do with the remainder? If anybody's interested, I can go ahead and talk about it. I'll just do it kind of briefly. You would do the same thing. I would go ahead and say, here's my quotient, 3x plus 2, and then I would go ahead and add the remainder over the divisor. Now, you remember, this slant asymptote, just like the horizontal asymptote, is going to help me with the end behavior, right? Hello. Tia. Thank you. So you remember how we wrote our limit statements? So, for example, the limit as x approaches, let's say, positive infinity. We're looking at the right end. Okay. Now, we're not going to substitute in for this first x because I need this. That's the slant asymptote. But I'm going to go ahead and plug infinity right in here. So what happens to the value of a fraction if the denominator becomes infinitely large? Well, let's think. Let's say I have 1/2, 1/3, 1/4, 1/5, 1/6. What's happening to the actual decimal value the larger the denominator gets? It's getting smaller. So what happens if your denominator is infinitely large? The value itself is really small, infinitely small. Basically, it's so small that we don't need to worry about it. Now, you may or may not have to do that when you get to calculus. It depends on your instructor. I can see Mr. Heinrich doing this, but all we're interested in right now is just figuring out what that asymptote's going to be. Okay. So all I want to look at is just going to be the long division. Now, I went ahead and made the decision early this morning. If you take a look at number 6, it really is super, super close to the example we just did. In fact, it was so close, I decided I just went ahead and pulled an example from my pre-cal book. Okay. Now, this one here, if you take a look, this one has a power of 3. This one's a power of 1. So actually what I would be finding here is a quadratic asymptote. Okay, so I'm not really worried about that aspect of it. At this point, we're just practicing the long division. We just want to make sure that we understand the process. So let's say I want to take x minus 3 and I want to divide it into 6x cubed minus 25x squared plus 18x plus 9. 6 what? There we go. So I'm starting with this term x right here, the leading term of my dividend. Gabriel's absolutely right. The first term has to be 6x squared. You always want to match up the first term that you're dealing with in the dividend. Okay, and now we distribute 6x squared times x, and then 6x squared minus 3. Okay. Now what do? Now we subtract. Again, this is where you have to be careful because this is where I see a lot of mistakes made. 6x cubed minus 6x cubed, again, they're gone. But negative 25x squared is subtracting a negative. What happens when you subtract a negative? It becomes positive. So negative 25x squared plus 18x squared, that's negative 7x squared. Bring down the next term, and you start the whole process again. Okay. How are we doing? How many folks remember this? Okay, so some do say no. Okay. All right. So let's see here. Mackenzie, x times what would give me a negative 7x squared? There you go. Now here's the thing. These are, pretty straightforward. It is possible that your term might turn fractional. And for some people, it's kind of hard for them to visualize that. If you're ever not sure what your next term is, take what you need. Like here, I need it to be a negative 7x squared. Okay. Go ahead and divide that by the leading term in your divisor. So if you go ahead and take a look at that, that x cancels with that x. There's your negative 7x. It works every single time. Okay. So minus 7x. And now we distribute. Negative 7x times x. Negative 7x times negative 3. Okay. And now we subtract. Okay. So once these cancel out, they're gone. The leading terms will always cancel. Okay. Felipe, how many x's do I have? Negative 3. 18x minus 21x. So a negative 3x. I'm going to pull down this last 9, and we got to do it one more time. Okay. All right. Keziah, x times what is a negative 3x? Okay. 3, but we need something. No, not it. Just one little item. Instead of plus 3, it needs to be minus 3. There we go. Now I've got my last term, so I distribute. Negative 3 times x. Negative 3 times negative 3. Okay. So now I subtract. Once again, those are going to cancel. But this time, 9 minus 9, what's my remainder? 0. Now, this is actually pretty nice. This is just a side note, especially if you're ever factoring something and you're having trouble doing it. Division is actually a great way to do it. Because I found out that the remainder is 0, I know that x minus 3 has to be a factor of that dividend. So see, I can easily now go ahead and factor my answer and continually break it apart. Okay, just throwing that out there. Did your algebra teacher ever show you the remainder theorem or the factor theorem? Those sound familiar? Okay, that's okay. That's okay. All right. All righty. And we won't go ahead and finish up this entire problem. For one, I don't think we're going to have enough time. But there is something that I want to go ahead and show you on number 7. Okay, so we've got function g is x cubed plus 4x squared minus 12x. And then we're going to divide that by x squared plus 7x plus 6. Okay, well, there's a noticeable difference here, right, Moses? Okay, instead of a binomial divisor, what do we got? We got a trinomial divisor. Okay, so I can still do the same thing. I can take x squared plus 7x plus 6, and I can go ahead and divide it into x cubed plus 4x squared, and then minus 12x. Okay. And it's going to give me exactly what I need. Okay. But sometimes, and this is why it's always a good idea, I think, to go ahead and just factor it before. Let's go ahead and do that. Let's factor it before we do this division. Let's see if anything happens. Okay. You notice anything about the numerator? There's a what? There's a GCF. Okay, so I can factor out an x. Now, if I factor out that x, that's going to leave me x squared plus 4x minus 12. Okay. So that trinomial, we can go ahead and break that apart. Let's see. Two numbers that'll multiply to give me negative 12, but add to give me 4. Okay. Which one's negative, though? Okay, so it's got to be x plus 6 and then x minus 2. Everybody's okay? All right. Let's go ahead and factor the denominator. There's no GCF. Two numbers that'll multiply to give me 6, but add to give me 7. 6 and 1. So I'm going to go ahead and say x plus 6, x plus 1. Okay. Do you notice it? What was I referring to? There you go. Because I'm able to cancel out a common group, that tells me there's a what? There's a hole here. But because part of it's simplified, this can actually make my job a little easier finding that slant asymptote. I can take what's left. I can take the x divided by the x minus 2, and I can go ahead and divide it by the x plus 1. So what this means is I'm going to take the x plus 1 and divide it into the x squared minus 2x. Okay. The answer I get here will be the same slant asymptote that I'm looking for if I were to do the original division. Okay, so it is a good idea. Take a look to see if anything can reduce, make your life easier. Okay. Now, unfortunately, we don't have time to go through both of these. If anybody wants to come in, I can walk you through it. But let's go ahead and take care of this bottom one here. Okay. X plus 1 times x squared minus 2x. Do you want me to give you an opportunity to try this one on your own? Okay. So try this one. Let's see what we can walk away with. Now, we know this one, you'll notice the degree up top is 3, the degree down below is 2. So this should be a linear slant asymptote. You should be getting something in the form mx plus b. Like I said, that's primarily what we're going to be working with in here. At least I have not seen anything different in the resources. Okay, let me go ahead and catch up to you real fast. So let's see. Hey, x times what? Give me x squared. X. So I'm going to place that up top. We'll distribute x times x, x times 1. Okay, now we're going to subtract. All right, those are going to cancel. So let's see here. Sonny, how many x's do I actually have? Close. What type of 3x? Negative 3x. Negative 2x minus x. Now, you may have noticed, remember I said that if a term is missing, we have to account for it with a 0. Same thing goes for the constant. So it's really no more than just a placeholder so that your like terms always line up. All right, so in this case here, I'm just going to go ahead and do this one more time. Bring down that plus 0. X times what is a negative 3x? minus 3. Okay, 3 times x, or excuse me, negative 3 times x. Okay, then we have negative 3 times 1. Go ahead and subtract that. And it looks like I have a remainder of 3. But remember, I'm not really interested in that part. All I want is the equation of that slant asymptote. Okay, how many folks got x minus 3? All right, questions. Anybody having a hard time? Oh, yeah, so I'll go ahead and write y equals x minus 3. Okay. And then we will, after talking about the quiz tomorrow, we'll quickly finish this up, and then we'll have our SEL. Okay. All right, good job.